All right, 2.3, apply deductive reasoning. I'm going to write out the definition for deductive reasoning. Deductive reasoning, using facts, definitions, accepted properties, and logic to form a logical argument. So, unlike inductive reasoning is when you observe a pattern and you make an educated guess or a conjecture about that pattern. In this case, you're using accepted statements, things that you know for a fact are true, and you're drawing a conclusion that must be true because those things are true. For example, the law of detachment, if the hypothesis of a true conditional statement is true, then the conclusion is also true. The law of syllogism, if hypothesis P, then conclusion Q. If hypothesis Q, then conclusion R. If hypothesis P, then conclusion R. You could also write this like this. If P implies Q and Q implies R, then P implies R. This is also called the chain rule. Okay? So for example, if two angles have the same measure, then they are congruent. You know that the measure of angle A equals the measure of angle B. Okay? So because this satisfies the hypothesis of a true conditional statement, then the conclusion is also true. Angle A is congruent to angle B. Because if they have the same measure, then they're congruent. We know that they have the same measure. Therefore, they must be congruent. Okay. Jesse goes to the gym every weekday. Today is Monday. Okay, so first identify the hypothesis and the conclusion of the first statement. The hypothesis is if it is a weekday, and the conclusion is then Jesse goes to the gym. Today is Monday satisfies the hypothesis of that conditional statement. So you can conclude that Jesse will go to the gym today. Okay? Alright, let's go on to page 2. If possible, use the law of syllogism to write the conditional statement that follows from the pair of true statements. Alright, so A, if Ron eats lunch today, then he will eat a sandwich. If Ron eats a sandwich, then he will drink a glass of milk. So, here's my P. Here's my Q. So I have P implies Q. Here's Q again. And here's R. And we have Q implies R. So, once again, the law of syllogism says if P implies Q and Q implies R, then P implies R. Okay, so the conclusion of the first statement is the hypothesis of the second statement. So you can write the following. If Ron eats lunch today, that's our P, then he will drink a glass of milk. That's our R. Okay? Alright, so for this one, if x squared is greater than 36, then x squared is greater than 30. If x is greater than 6, then x squared is greater than 36. Now, in this case, they put things a little bit out of order. They made it a little bit harder for us this time. Here is our P in our Q. And here is our Q again, implying R. Okay? Because we know this because this is the repeating segment. Okay, so that's why this has to be Q. So basically they just reverse the two statements. Okay, so what we'll say is P, if x is greater than 6, then R. X squared is greater than 30. Okay. So third one, if a triangle is equilateral, then all of its sides are congruent. If a triangle is equilateral, then all angles in the interior of the triangle are congruent. Okay. Now, notice that neither statement's conclusion is the same as the other statement's hypothesis. Basically, there is no repeating Q like in the first two statements. So, you cannot use the law of syllogism to write a new conditional statement. Alright, I'll let you guys try these two. Let's go on to page 3. What conclusion can you make about the sum of an odd integer and an odd integer? Okay, so let's look for a pattern in several examples. We have negative 3 plus 5, that's 2, negative 1 plus 5, that's 4, 3 plus 5, that's 8, negative 3 plus negative 5, that's negative 8, 1 plus negative 5, that's negative 4, 3 plus negative 5 is negative 2. It looks like if we add two odd integers together, we will always get an even integer. Notice how each of these are even numbers. Alright, let n and m be any integer. Use deductive reasoning to show that the conjecture is true. 2n and 2m are even integers because any integer multiplied by 2 is even. 2n minus 1 and 2m plus 1 are odd integers because 2m and 2n are even integers. So basically what this is saying, whatever n and m are, if you multiply it by 2, you're going to get an even number. If you plug in a 1, you're going to get 2. If you plug in 5, you're going to get 10. Plug in 13. No matter what number you plug in, you're going to get an even number. Likewise, if you subtract 1 or add 1, you're going to get an odd integer. So 2 times 1 minus 1, that'll give you 1. 2 times 5 minus 1, that'll give you 9. 2 times 13 minus 1, that'll give you 25. And if you were to add 1, you would still get an odd integer. Okay? So, 2n minus 1 plus 2m plus 1 represents the sum of an odd integer, 2n minus 1, and an odd integer, 2m plus 1. So basically, we know that this has to give you an odd number, and this also has to give you an odd number. So if I add them together, it's like I'm adding two odd numbers together. 2n minus 1 plus 2m plus 1. This gives you 2 times n plus m. This is because the minus 1 and the plus 1 cancel out, and I can pull out the 2. The result is the product of 2 and an integer, n plus m. So, 2 times this is an even integer. Because if you think about it, whatever n and m are, if I add them together, I'm going to get some number. And if I multiply that number by 2, that number has to be an even integer. Okay? So this kind of acts as a proof that the sum of an odd integer and another odd integer is an even integer. Alright, I'll let you guys do this checkpoint. Let's go on to page 4. Tell whether the statement is the result of inductive reasoning or deductive reasoning. Explain your choice. Alright. The runner's average speed decreases as time spent running increases. Okay, so we're looking at this. It looks like this is in fact the case. As the time increases, the average speed is decreasing. Okay, that looks like the pattern that we see here. Now, because we are observing a pattern in the data, this is inductive reasoning.
Sorry. Down here is where we keep the society simulator so you can beat up folks while wearing someone else's costume.
Alright, the runner's average speed is slower when running for 40 minutes than when running for 10 minutes. Okay, well, 40 minutes, that's here. 10 minutes that's here, yeah, when he is running for 40 minutes, he's a little bit slower than when he's running for 10 minutes. This is deductive reasoning because you are comparing actual values given on the graph. You're not just looking at the pattern anymore. You're actually looking at given facts, given information in this graph here. All right, and you guys can do these on your own, and that's all.